Alright, time for a review of some of our applied geometry stuff, similar triangles and volume things. I did want to make a quick note in the video that your final is not going to have this stuff. You don't have to draw a dilation. It's primarily going to have a volume question, and it's going to have a similar triangles question. So the examples in here are focusing on those. Though you should know the other things, you just keep that in mind. Alright, so we're going to do a couple similar triangle problems so you can see them, and a couple of volume ones. Alright, so we're going to look at number 5. We need to solve for x, and the triangles in each pair are similar. That's going to be important for, figuring it out. So we got this small triangle is similar to this large one, and we do need to figure out what the scale factor is, which I call SF. What do you times the small one by to get the big one? Well, to figure that out, you have to figure out from what side goes to what side, and you can figure that out in the names here. So if you look at RS, that's the last two letters, that's going to be similar to the last two letters of the other one, which is VW. And so this 3 is going to go to 9 there. So 3 times something is going to equal 9. And that something is going to be 3. You can divide both sides by 3 and get it. So that's our scale factor. Scale factor is 3. Which means if you take this part and times it by 3, you will get 18. And so that makes an equation. 2x minus 12 times by 3 is going to equal 18. Yeah, and so that makes an equation. That's usually the hard part. If you don't set up your equation right, you get the wrong answer. The rest of this is normal solving stuff. You can distribute the 3 if you like, or if you're like me, it's like, oh, well, we don't have to distribute because we can divide by 3 because it goes evenly. Sometimes it doesn't go evenly, in which case you probably want to distribute. Anyway, so we got 2x minus 12 equals 6, and then you can add some 12, add some 12, and then we got 2x equals 18. Whatever, it's what it is. And so you can divide by 2, and you're looking at x is 9. So voila, we got 9. Let's try another similar triangles one. On this one, it looks like we have a small length here that goes to a bigger length of 12. So 8 times something equals 12. That's not a nice integer, and that's okay. That's pretty common. To figure out what the fraction would be, you're just going to divide both sides by 8. 12 eighths does reduce. You can divide top and bottom by 4. That'll give you 2 thirds. Sorry, 2 thirds. 2 on bottom, 3 on top. 3 halves. And so that's our scale factor, which means we can take this 14 times by 2 thirds. Sorry, times by 3 halves. Look, and you'll get the long length. So small length times scale factor will get big one. And so 14 times by 3 halves is going to equal 3x minus 3. 14 times 3 halves, let's see, I'm going to use the magic of calculator to figure that out, because I'm lazy. It gives you 21. So now we got 21 equals 3x minus 3, and the rest of this is just basic solving stuff. You add some 3, you get 24, equals 3x, divide by 3, and you got that x is 8. And voila, we figured out x on this one. So step 1, get your scale factor. Step 2, set up equation, and then solve the equation. I don't know. Those are terrible steps. But yeah, that's basically it. Figure out what the small ones get times by to get the big one, and then set up an equation that uses that. Let's jump over to volumes. You should hopefully remember your volume formulas, but if you don't, it's here. I put a link in the module for the volume formulas, and you're going to use these to get volume. Let's start off with this one. To get the volume of a shape, you have to figure out what kind of shape it is. This one is actually this kind here. It's got a triangular base down here, and then it's got a height, I guess, in it. So you're going to get the area of your base here, and then times by the height. And that's kind of the volume formula for most of these things. To get the area of a triangle, that's base times height. And the base, sorry, 1/2 of base times height. So area of a triangle is 1/2 of base times height. And the base and height of a triangle, they need to meet at 90 degrees. Like, they have to meet at 90 degrees. If they don't, then they're not the base and height. And so we're actually not going to use 10 to get us this area, because 10, the 10 and the 8 don't meet at right angles, but this length and 8 do. And this one's 12 coming from this guy up here. So we got 12, the area of our little triangle here is going to be 1/2 of 12 times 8. Let's see, 12 times 8 is 96, and you got to divide that by 2. It gives you 48. So there's the area of my my small triangle there. But that's just the area of the bottom. We need to times by the height of this shape, which that height is 7. And so the volume of this guy is going to be 48 times 7, which I don't have that memorized, really. Yeah, I broke it. All right, 48 times 7. 336. And this is all in cubic inches. So voila, we got a volume. Let's try another one. This one is not the same as the previous one. They're similar. There's triangularness to them, but this one's actually a pyramid, but instead of a square bottom, it's got a triangular bottom. And so it's the same volume, same formula as this, except we have to cut it in half if you're going to do a triangular base. So let's get the area of the base here times by height. So the area of the base here, again, the area of a triangle is going to be base and height, and those meet at the right angle. So find the sides that hit at a right angle, and those are it. So you got 3 and 4. So the area of my little triangle here, that's a bad triangle symbol. Area of my triangle here is going to be 1/2 of 3 times 4. 1/2 of 3 times 4 is 6. So that's the area of my little triangle down here. And then I need times by the height of my shape, which is 6. So I need to do 6 times 6. That's going to be the close to my volume. Once you've done that, though, since this is not a prism like the previous one, we actually need to take that volume and cut it by 1/3. The volume of pyramids and cones are 1/3 the volume of cylinders and prisms. And so we're going to take this and times that by 1/3, and that will be the volume of this pyramid. 6 times 6 divided by 3 comes out to be 12, and voila, we got this volume of 12 cubic miles, which is fairly large. And then we got one more I want to do on that had circle involved. So we're going to do the volume of a cylinder. The volume of a cylinder is going to be pi r squared times height. So here is our radius of our circle, and then the height, quote-unquote height, of our cylinder is 12. And so really we're just plugging our numbers in. We got pi times 10 squared times by 12. And that's something you can put in the calculator. Let's see, if we do 10 squared times 12, you're looking at 1200 pi. And if you plug in the pi value, you get your approximate value there, which comes out to be about 3,769.91 cubic centimeters. And voila, we got our approximate volume. So, just quick overview, similar triangles and volumes. Make sure you know how to get both.